In the last part, we will discuss analysis of water sample. Do you know in water quality, certain parameters should be analyzed in situ or on site immediately after the sampling to avoid physiochemical changes that may occur during transit and storage. Parameters such as temperature, pH, DO, electrolyte conductivity, TDS and turbidity should be measured using portable multimeters. For samples, for a few parameters required in situ filtering and preservation. Gran plot method is used for determining the bicarbonate concentration in situ. Biological and temperature sensitive parameters such as nutrients and alkalinity required to be determined within hour of sampling. These analyses can be carried out in a mobile laboratory. Some laboratories, however, measure these in a permanent laboratory within the 7 days of sample collection. Therefore, portable car chiller or nitrogen storage tanks are used to keep the samples under less than 4 degrees centigrade until reaching back to the laboratory. Participants, several ex situ analyses required to be carried out once samples are back to the laboratory. However, samples should be processed and preserved before storing for the analysis. For trace metals and major cations, as we have discussed earlier, in situ filtration, acidification with ultra pure, suprapure nitric acid is mandatory. Besides, samples should be stored in pre-cleaned and acidified bottle should be preserved at lower temperature. Also, for some cations and anions, sample can be filtered in situ or ex situ and preserved till the analysis. The BOD test is generally based on a 5-day incubation method at 20 degrees centigrade, which should be started immediately in the field, preferably within 4 hours after the sample has been taken. Chemical oxygen demand requires complete oxidation with a very strong oxidant mixture such as potassium dichromate and sulfuric acid. If there is any delay before analysis for COD, the sample may be preserved by acidifying with sulfuric acid. The summary of the analytical method can be shown here. Moreover, for developing a basic water quality laboratory, certain space and items should be acquired. For example, there should be adequate space for essential services, facility for a distilling apparatus and adequate supply of volumetric and other laboratory glassware. A lab should have standard chemicals and reagents for the parameters to be measured and an analytical balance. Portable equipments like ion selective electrode for pH, conductivity, DO, turbidity, water testing kits which are helpful in field and lab analysis. A lab should have general purpose equipments like an oven, muffle furnace, hot plate, microwave digester, autoclave, BOD incubator, centrifuge, water bath, bacteriological incubator and equipments and also a refrigerator. As the requirement to measure constituents at low concentrations, consideration should be given to procuring advanced and sophisticated instrumentation such as ultra pure water purification system to produce type 1 water for trace element analysis, auto analyzers, benchtop multimeter, UV visible spectrophotometer, etc. Based on objective and parameters to be analyzed, lab may have one or more state-of-the-art instruments such as ion chromatography, atomic absorption spectrophotometer, GCMS, GCMS-MS, HPLC and inductively coupled plasma mass spectrometry instruments. Labs required to measure sediment sample for major oxides and trace components may have X-ray fluorescence instruments. At the same time, X-ray powder diffraction equipment is useful in characterizing the sample for the presence of minerals. Lab may also be equipped of ratio mass spectrometry for measuring stable isotopes and HR ICP-MS for radiative isotopes. These instruments are costly, but they are reliable solution to generate high quality analytical data. Moreover, all scientific instrument and equipment must be thoroughly checked and evaluated before the final acquisition. The most important aspect of water quality analysis is quality control and quality assurance of data. It is a crucial aspect of water quality program to produce reliable data. Therefore, precautions should be taken while choosing an analytical method free from bias and interferences. The detection limit of a particular method and instrument should be known. Instruments should be calibrated using reference standard with the correct matrix. It is necessary to check the precision and accuracy of the analytical results. Accuracy is the difference between the measured value and the true value. It is the most difficult quality parameters to measure, since you generally do not know what is the true value is. The most common way of estimating accuracy is by checking using sample having known chemical concentrations. This type of sample is known as a certified reference material. There are several certified reference materials from various organizations. Next is precision. It expresses the closeness of the agreement or degree of dispersion between two duplicate samples that are taken in the same place and time, or the percentage of relative standard deviation of a series of measurements. One example of accuracy and precision is shown in this figure. You can see the difference between the good accuracy and poor accuracy. Same for the precision. Also, another aspect is reproducibility of analytical results. A group of laboratories can check it to achieve comparatively of results by comparing the precision and accuracy of each laboratory. Furthermore, the error can be caused by changing the sampling procedure and analytical method between each group of samples. So, this should be consistent in each time for all samples. It is essential to have routine maintenance of laboratory equipments, glassware and reagents. It helps in enhancing the internal and external quality control of laboratories in an organized manner. After analysis, we have to also check the cation anion balance. It is the sum of positive charges should equal the sum of negative charges in solution, that is electroneutrality. The extent of charge imbalance can be characterized by the normalized inorganic charge balance. Now, I would like to discuss the common mistakes in water quality monitoring and analysis. As water quality analysis is not rocket science, even a 16-year-old can do this job successfully. Here are some common mistakes or sorts of errors people do during sampling and analysis, such as not selecting a sample that representative of the respective water location, not having pre-cleaned sample bottles and not rinsing the sample bottle thoroughly. For groundwater, monitoring wells must be fluxed 4 to 5 times before sampling. Another problem is not choosing a correct filtration technique and not following appropriate preservation method at the field and storage during the field trip and back in the lab. Not closely following the instruction provided by the manufacturer of the chemicals test kits used at the sampling sites. Problem may also arise if an air space of at least 2.5 cm between the surface of the liquids and the container lid is not maintained. It helps to produce a homogeneous sample for laboratory analysis, and also not carefully close all containers tightly after sampling. Besides, bottles will not break after refrigeration. Many times, the samples are not cleaned properly between successive samplings. Samples should not be kept too long. Many times students and scientists miss to calibrate field devices or instrument at the required frequency before analysis. Expired chemicals should not be used. Due to cost and logistic issue, many labs not follow quality control procedure and use certified reference material to check the reliability of a dataset. Besides, many labs do not follow standard methods or protocols for the examination of water samples. Let's quickly summarize this lecture. The quality of both surface and groundwaters is governed by a set of complex interacting physical, chemical and biological processes that determine water for various uses. However, in recent years, due to pollution of freshwater resources, raised concerns among the user and guidelines are proposed stating the permissible limit of various parameters affecting the water quality and uses. Characterizing water resources for these physiochemical parameters become the norm of the day. Therefore, this lecture describes some basic requirements, procedure and information on sample collection and analysis. Thank you.